G'day ladies and gentlemen, it is the Raging Ranga here, and welcome back to your introduction, your quick crash course on linear equations and simultaneous linear equations. I'm speaking so fast, I'm abbreviating words that don't need to be abbreviated. So, when we're talking about simultaneous linear equations, that means solving two equations at the same time. We have two bits of information, x and y, and we've got two equations with which to find what x and y actually are. If I said to you that x plus y equals 13, and I said, alright, go and find me what x and y are to satisfy this equation, well, there's lots and lots of different things it could be. X could be 12, y could be 1, x could be 7, y could be 6. There's not enough information here to give a decisive answer on what x and y are. That's why together like this just forms a line, because there's infinite possibilities of where if x is some number, y will be some other number, that when I add x and y together, I get 13. So what simultaneous equations do is they limit it to one value for x and one value for y by setting two parameters that both must be satisfied. So not only can in this example, can x plus y equal 13, but two lots of x and three lots of y must also equal 31. So if I said x was 1 and y was 12, well, if I plug that in here, I get two lots of 1, which is 2, plus 3 lots of 12, which is 36. 36 plus the 2 is 38. That does not equal 31. So you can see right there, 1 and 12 does not simultaneously satisfy both the x plus y equals 13 equation and the 2x plus 3y equals 31 equation. Now we could spend a long time trying to figure out values that satisfy both. I could try 2 and 11. I could try 3 and 10. I could try 4 and 9, etc. And that's not including that y could be a negative number. X could be 14, y could be negative 1. And then I'd have to try that. It's just going to take too long, and as a very wise African-American woman once said, ain't nobody got time for that. So we need a slightly smarter way of doing it, and that is simultaneous equations. Okay, so how do we do simultaneous equations? By being clever. First of all, the graphical solution. These things here, x plus y equals 13 and 2x plus 3y equals 31, they're a certain type of linear equation, aren't they? What kind of linear equation are they? Yes, that's right. They are general linear equations. Fantastic. So, that means I could draw a graph for both lines. I could draw both lines as a graph. Okay? I could draw both of these equations as lines, or as linear graphs. So, x plus y would probably look a little something like that first one would look like that, and the second one would probably look a little bit like let's see, probably something a bit more like that. So they'd meet somewhere up here, meet somewhere up there. No, that's not right at all. No, I'm going to backtrack that. It's going to look something more like that. Sorry. So, notice that they cross at one point. At one point, both the x and the y value are the same for both lines, or for both equations. And that is the coordinate point we want, because that's the x and the y value that satisfies both equations. Both lines cross at that one point. Both lines are satisfied at that one point. So we can do this graphically. So in this example here, using the graphical solution to simultaneously solve for these two equations, so to find the x and y values that satisfy both equations. We draw these graphs using the methods we talked about in part A. You draw the lines, you get the point where they meet graphically, so this could be using a calculator or hand drawing these graphs, and you get the point there. Okay, you draw it and you find the point visually. So that's one way of doing it. Give these questions a go here. Okay, so hopefully what you found from that last section is that drawing them takes a little bit of time, and one thing that we don't like doing in maths is taking lots of time. We like to do things nice and quick so our businessmen overlords can make more money. So what's a quicker way of doing this? A thing called solution by substitution. This is a quicker, less visual, but more efficient method. We substitute one equation into the other one. What do I mean by that? Well, I know by this first equation that y equals x take 3. Y equals x take 3. So why not replace this y with x take 3? Just replace the y with x take 3. And then in this bottom equation, we are left with only x's. We're just left with x's, so we can tidy up that equation, find what x is using this substituted equation down here, and then using this top equation, we can put in the value of x we find into here and find what y is. You should also find that if you substituted the x equation back into this original equation here without that y value substituted in, you'll get the same value for y here as in this equation. So what do I mean by that? If we call this equation here the first equation, this equation the second equation, substituting 1 into 2 gives 2x plus 3 lots of y. But remember, we're replacing y with x take 3 because we know that y equals x take 3. We replace it with x take 3, and that all equals 16. So our newly formed second equation becomes 2x plus, do a bit of expanding, 3x take 9 equals 16. Reduce that down and you'll get that x equals 5. Pop x equals 5 either back into this equation or into this equation, find out what y is, and you'll get the same answer. So let's see. Substitute x equals 5 back into the first equation. You'll get y equals 5. Remember, we're placing the x in as 5 now. Take away the 3, you get 2. What if we did that over here? We did 2 lots of 5 plus 3y equals 16. Well, if you simplify that, you're going to get 3y equals 16. Take away the 2 times 5, which is 10. So 3y equals 16, take 10, which will be 6. Get rid of this 3 times here. We'll end up with y equals 6 divided by 3, which is 2. So same answer, either equation you use. That's pretty cool, hey? And as this guy here's pointed out, he's quite right. Give these questions a go, and we'll try one more method in a moment. Okay, last process you can use here is solution by elimination. And this method is perhaps for the more abstract-minded of you, and this is probably the quickest way to do it if you're canny enough, if you're good with picturing numbers in your head. So look at these equations here. We've got 5x take 2y equals 7, 3x plus 2y equals 17. In this method, basically, if you've got the x or y value the same size but opposite sign, we can eliminate them. We can combine these equations and eliminate certain things. Okay, it sounds a little confusing right now, but let's have a look here. What we want to do is we want to add these two equations together. We want to add them together and see what happens. So here we go. 5x take 2y equals 7, 3x plus 2y equals 17. If we add these equations together, literally just straight down, so x's with x's, y's with y's, and constants with constants, find out what you get. 5x plus the 5x plus 3x will give you 8x. The minus 2y plus the 2y will cancel out and you've got no y's left. Then last of all, 7 plus the 17 will give you 24. We've got our brand new equation. You could call that equation 3, which only has x's in it. So we're left with 8x equals 24. That means that x equals 3. Then you stick x back into either one of these two equations here, solve for y. If you realize that they're not exactly the same, like in this case, for example, there's 3x here, 2x here, 4y, negative 3y here, you might need to do a little bit of fiddling around with them. You might need to times one equation by a certain number, times the second equation by a different number. And you can do that as long as you times all the numbers, all the terms in each equation by the same number. Let me explain. Here we have 3x plus 4y equals 2, and then we have 2x take 3y equals 7. We can get rid of either the x values or the y values once we get the same coefficient out the front. So if I ended up with 3x here and I had a negative 3x here, or a 4y here or a negative 4y here, something like that. Okay, we want the same coefficient. So what they're doing in this case is they're going to try and get rid of the y's, because the y's already have a positive y and a negative y. That's going to make it easier when we add the two equations together. So let's get the coefficient out the front of the y as the same, but keep this negative here and the positive here so they cancel out nice and easy. Here we go. If I times this 4 by 3, if I times this entire equation by 3, I'll end up with a positive 12y. And if I times this equation here by 4, I'd end up with a negative 12y. So those would cancel. But like I said, you need to do the same thing to all of the terms in the equation. I'd need to times this 3x and the 2 and the 4y by 3. I'd need to times this 2x and this 7 and this negative 3y by 4, which is exactly what they've done here. So times the entire first equation by 3, times the entire second equation by 4, and you're going to end up with these two new equations here. If we add these equations together, we're going to get 9x plus 8x, 17x. 12y minus 12y, no y's left. And 6 plus 28, 34. Solve for x. Put that x value back into one of these equations, get your y. And that's it there. Another thing to note is that you don't just have to add these equations together. You could decide to take these equations away. For example, I could have easily times this entire first equation by 2, this entire second equation by 3, then I'd end up with a 6x out the front here and a 6x out the front here. But this time I'd need to do the first equation, take the second equation. What that would do is that would cancel out the x terms, and I'd solve for the y terms and then substitute back in to find x. So give those questions a go there, and you will then be a professional at doing simultaneous equations by hand.